we were discussing about the error propagation, which we considered as one of the prominent phenomena which will take place whenever we, collect the data and do certain, or compute some certain indirect quantities. So it will automatically propagate. So we discussed this and we finalized that this was the uh, equation which we have to follow. Obviously, we also discussed about the non-linear solution and as well as linear solution. So for a linear solution, we simply wrote A sigma xx A transpose if your function looks like this, y is equal to ax plus b. And if your function is non-linear, then it would look like something like this, which is where you will use the Jacobians or sort of matrix of partial derivatives that will help you in case of trying to find out the error propagation. So this was the basics. Okay. Later on, we'll move on towards few more conceptual understanding, and then we'll get back again to the problems. Okay, so just like error propagation, we were looking into, isn't it? We were looking into VCV propagation, which we call it as uh, variance covariance propagation. So mostly we discussed about the uncorrelated case where your the raw matrix or the initial matrix is uncorrelated, and majority of the time you found out your final matrix are also uncorrelated, but that's not always true. So in order to extend our understanding, conceptual understanding, which we call it as a covariance propagation. Covariance propagation is one is y1 is a function of x1 x2, y function of x2 x2. So we try to form just like in previous slide, previous lecture. I told you, no, there was a clear case. We can, you have theta, you have d. One I was asking about h, isn't it? If somebody was asking about t, this height, so you could be writing two equation. T is equal to d sine theta, isn't it? And another equation is h is equal to d cos theta. So while we were trying to identify, let me just again redraw, rewrite in case it is visible. So what I'm trying to say, suppose I was interested in finding out this height t, I would be writing d sine theta, and h would be d cos theta, isn't it? So this is a y1, y2 kind of function, but they are function of d and theta. So that's how you try to understand how these two functions are written. Y is equal to x1 and x2. So you could consider here x1 and x2 as d comma theta, d comma theta, and you can consider y1 as t, y2 as h. So that's how you could relate in your mind how these functions are usually prepared when we are talking about the covariance propagation. So again, next, it is very simple. You write like this. You try to form, if you know that this is a non-linear, you will form and write solution like this. And if it is a linear one, then you will write as, say, sigma yy a sigma xx a transpose. This is sigma, the capital sigma we call it, because we are talking about a multiple number of observables, so that there are not only single variable, there are multiple variables. The moment multiple variable comes, how they will take shape, that's why this slide is presented like this. How they will take shape, you see in the next slide. You see here the sigma yy is nothing but, you try to focus on the component. What are the component for uh, the variance covariance matrix on both on left hand side as well as on the right hand side? You just take a look at it. Okay. So I hope you get it. There is one first component, which is this sigma y1 square. This is second component, sigma y2 square, and obviously the other non-diagonal elements are the covariances, isn't it? And the Jacobian, which I have told you, on the row side, you will go with number of variables, which I will call it as u, and on the column side, sorry, on the row side, you will go with the number of function, which I call it as n, and on the column side, you will go with the number of variables, which is u. So that's how you have two variables, two function. That's why the matrix becomes 2 cross 2. Similarly, the input variance covariance matrix and corresponding the Jacobian transpose. So I hope it is very much clear, and that's what we were doing in the previous 2-3 classes about writing about the same. This is an extended version of the same, which we were interested in finding out, and in fact. This would help us in some way or other when we were asked question about certain variance covariance metrics, but we have to multiply the all available so-called component in the matrices. So see here 2 cross 2. If we have to write 2 cross 2, it is 2 cross 2, it is 2 cross 2. So all matrix output would become 2 cross 2, isn't it? So that's how you'll write sigma y1 square, sigma y2 square, sigma y1 y2. That because some way or other these are the output which people are interested in. Obviously, it would be much easier if you working with MATLAB or Octave or any kind of scientific programming software where you will simply insert the matrix and matrix it will do the multiplication. But in general, how the multiplication will take place, this is the we are just opening up the different segment. So this is a covariance propagation, which popularly known as. Any questions? Any question on the structure? Why we are writing this? Why we are writing this? If you have any doubt, this is the high time we should ask. If it is still a little confusing, you can ask right now, because now we are moving towards another concept for which we have to cover apart from error propagations. No question. Okay. So in a similar manner, we are explaining it for different types of problems where we have multiple uh, I would say the variables x1, x2, xn, and then we are extending it in this. But it is very tedious task to look into this kind of solution, because now you have matrix solution with you. You do not need to worry about all these multiplication, isn't it? You do not have to do it. Your software will do it. Your MATLAB or Octave or any kind of scientific programming software will do it. You need not to worry about it. You just need to worry about how the Jacobians are taking place. If you are doing it right manner or not, you just need to understand number of function and number of variables. This is a very common understanding if you are following it. Okay, so next come the cross covariance matrix. Cross covariance means we are not focusing on sigma yy. Instead, we are focusing on sigma xy. Please remember, till now we were writing sigma yy, sigma xx, sigma zz, sigma tt, sigma hh, isn't it? We were writing like that. What do you mean by cross covariance? Obviously, we are interested in terms of how the two independent variables are related to each other, and we are trying to see that also. So instead of focusing on the individual variation in the vector, we are more focused towards two different variables. Let's say if it is there, just like in your previous case, you have just your theta, d, t, and h. So what is sigma ht? If somebody asks this, okay. So we were trying to identify that by solution. Although it is very easy to understand because you know the expectation. How do you writing? How you were writing for expectation for yy? I'm just writing it again for your better understanding. Expectation x minus mu x, and then again x minus mu x transpose. That's how you were writing for sigma yy, isn't it? But here for xy or between two, you would be writing about x minus mu x, y minus mu y transpose, x minus mu x and y minus mu y transpose. And similarly, you will again write for sigma yx, which is sigma xy transpose. So these are just conceptual understanding. No need to remember it because you know the basic derivation steps. See, I'm just giving you one explanation about cross covariance. See, y is related with ax, z is related with x as bx. So expectation of y would become a expectation of x, and sigma yy would become a sigma xx a transpose, considering this is a linear model. Okay. Then z is equal to bx. Expectation of z is b expectation of x, expectation of zz, b expectation. Sigma zz is b sigma xx b transpose. So this is. I hope it is very clear. I do not find any confusion from your side in this. What have been asked is sigma yz, isn't it? So how would you write expectation y minus mu y, z minus mu z transpose? Y you would write as ax, expectation y you know, a expectation x, similarly z, expectation z, and then you'll realize that it is nothing but a sigma. Anybody asking something? A sigma xx b transpose. See how it has changed from here to here. The change is very well clearly observed that it is now a sigma xx b transpose. Any questions? Okay. Now another important point, which is cofactor matrix. Now what is cofactor matrix? There is
सर
a
लास्ट लिख नहीं पाए थे अभी.
sorry.
सर लास्ट वाली स्लाइड अभी लिख रहे थे, थोड़ा सा लास्ट लाइन पूरा नहीं होता.
आप लिखने से ज्यादा समझने पे अगर फोकस करें तो थोड़ा मेरा ज्यादा सपोर्ट करेंगे. इफ यू आर फॉलोइंग इट then you should write. If you are not following it, then you first should ask how we are doing it. Is it okay?
यस सर. हो गया सर.
Okay. So our next discussion point is on cofactor matrix. Now, if you recall, we were discussing about variance matrix. Isn't it? There is another name of popularly we call it variance covariance matrix, but sometimes we also call it as by covariance matrix. That's fine. But this is cofactor matrix. It is slightly different from covariance matrix. In cofactor matrix, what is really being said that if you do not have the whole population with you, what is really happening in our Geo-Informatics case, when you take large number of infinite number of measurement for a particular quantities, then it is possible to calculate the variance. Suppose you are sitting in a class of 1,000 students. If you have to compute variance of some quantity, then you have to take the measurement, individually measurement of all possible 100,000 students. But is there any way, just like we discussed in the sum of the class, that is there any way to represent the same variance or a range of estimation procedure if, with the help of any kind of mechanism, you can compute or you can say something about the variance without being taking the individual measurement of so much large population. Then answer comes here, the cofactor matrix, where you do not have the large population to deal with. Instead, you are working with samples. For working with samples, you cannot call it as a variance covariance matrix, isn't it? Because you have to work with samples. You cannot tell it as a what should I say, the variance matrix. Instead, it should be named as something different, because variance belongs to population and you have not taken any measurement from population or complete population. Instead, you have taken measurement from the sample. When you are taking measurement from the samples, obviously our job is to give it a appropriate name. So that name is cofactor matrix. And in cofactor matrix, is the other names are also represented as relative covariance matrix, weight coefficient matrix, or cofactor matrix. These are the three names which popularly we are calling the representing the covariance. Now you can easily recall from your first terminology, which is relative covariance matrix. That means relative covariance matrix means it is related to covariance matrix, but it is not the actual, isn't it? So it is relative. Relative is always a word with respect to some reference, isn't it? So what we are telling here, it is a relative covariance matrix, which is with respect to some original or so-called variance covariance matrix. It is also known as weight coefficient matrix. Please remember, it is not the weight matrix I'm talking about. We'll discuss later on about the weight matrix, but it is weight coefficient matrix. Obviously, the another name is cofactor matrix. The reason for scaling of covariant matrix is seldom known beforehand, as it is generally derived from the limited number of samples instead of population. So that's why we need certain scaling vector. So in this equation, if I ask you to focus now on this equation, it is representing the small q representing the cofactor matrix, and the small sigma is representing the variance covariance matrix or a component of variance covariance matrix, and it is referred by this called one component called sigma naught square. So sigma ig, which is also sometimes written like this, sigma ig is sigma naught square qig, and this middle bracket represents the component of a matrix. Okay, I hope you get it. This sigma naught square is called as variance factor, reference variance, or reference variance associated with unit weight. Although the popular terminology is known as the reference variance and variance factor, which is helping you to relate with so-called actual variance squarence matrix. And similar to your variance squarence matrix, the Q cofactor matrix, which is Q, capital Q, is also square and symmetric. Please remember, this representing Q, this representing the sigma, and how they are related you can easily see. So popularly we'll write as like this. So I hope it is now very much clear. Any questions so far?
सर वॉइस नहीं आ रही।
अभिजीत बताइए।
सर एक बार फिर से रिपीट कर दीजिए। सर वॉइस नहीं आ रही थी, रिपीट कर दीजिए।
हाँ, okay. What I'm trying to say here is sometimes what is happening, you do not have access to all possible observations or so-called population. If you do not have access to all such observation that belongs to population, what will happen? You cannot know the exact variance squarence matrix. So how will you proceed? Because variance squarence matrix is an essential part of your adjustment procedure. So how will you proceed? You will proceed with an alternative. An alternative is called as cofactor matrix, or you could also call it as a, just like in your Bollywood films, the stunts are usually being performed by the stuntsman, because sometimes the main character doesn't want to hurt himself. So similarly here, you do not have access to variance squarence matrix, which we call it as sigma. Then what you will do, you will go one step ahead and try to find out an alternative. And in terms of finding that alternative, what you will do, you will access to this cofactor matrix that will be given on a sample basis. And this is related with respect to variance squarence matrix with respect to or using the help of reference variance or variance factor or reference variance associated with unit weight. Okay, and its square root is called as reference standard deviation. So what is more important for here? I'm just erasing this all. What is important to focus here? How it is written. You understand that how it is written? It is written as Q, which is nothing but the curly bracket which represents the matrix at value at different location, and it is 1 by sigma naught square sigma ij. That's how it is related. It's very important, very important. You cannot ignore this. It's very important. I hope it is clear. Now I'm moving ahead if you do not have any question. Now next point is weight matrix. Now as I've told you, what is weight matrix? It is very important because from the day one you were doing as the weighted mean, or you have chosen this weighted least square in terms of example for understanding. So here we need to introduce first what is weight matrix. So inverse of cofactor matrix, which is inverse of cofactor matrix. So weight matrix, if I representing by W, so it is inverse of cofactor matrix when it is square and non-singular and is called as weight matrix as W or P, or which is also known as Q inverse in terms of matrix. Okay. The term weight is used to express precision by way of inverse relationship. अब आप देखिए, I'm just giving one example. Forget about the literature. You will realize from your own experience. Suppose you have 10 friends. Okay. All maybe classmate or schoolmate, whatever it is. But you rely on only 2 or 3 friends of yours. You cannot rely on all. How? That is the nature. By their constant support, or any kind of means you can understand, you always rely on those 3%. Or suppose coming back to your family only. So you have 2, 3 siblings, mother, father, and out of these family member, you tend to rely on certain specific family member for any kind of support. Why? Because you give more weight to them, isn't it? That's how you do it. That's how we live our life. We try to give more weight to our priorities. Similarly, in the observation, you try to give more weight to that observation which is very precise. Or if you talk about a data set, you give more weightage. You are inclined to give more weightage to that data set which has lowest standard deviation, because it has more reliability or less dispersion, less deviation from the mean value. Similarly here, all these statements are now very much clear. If I just call one by one, term weight is used to express precision by way of inverse relationship. That means weight is inversely proportional to precision, which is very true. And in general, we write it as, or we try to represent it by variance. So weight is inversely proportional to variance. Okay. High weight means high precision or low standard deviation, which is very much clear. However, what is being said that this type of relationship is not true in general. What do you mean by that? It is meant that although this relationship exists, but it is proportional to the variance, the inverse of variance, or you simply said inverse relationship. But sometimes what happens, your lot of factors dominate this relationship. I'll give you one example. When we come to one problem, then you will realize it very much clearly. Another is term weight relating to individual elements of W should be totally restricted to uncorrelated case. Only then it is safe. This is what I meant. That means simply just by saying that W is related with where cofactor matrix inverse will not help you. Only in that case when your observations are uncorrelated. If it is correlated, you have to assign weight individually by your own experience. So what is the summary of this? You will assign weight by 2 mechanisms. First is either you have the uncorrelated measurement and then you can go ahead with the very inverse of cofactor matrix, or it is based on user experience. This is about the weight. For uncorrelated case, both Q and W both are diagonal. In general case, diagonal elements, which is Wi of weight matrix, are not just reciprocal of associated cofactor matrix. It is in general a relationship is being envisaged, but we do not have any such direct relationship. So it is generally being said that this is a way of approaching towards weight matrix if it is not provided earlier. Generally, what is really happening if you are working as a professional, the weight matrix or associated cofactor matrix are generally being given to you, or generally being you as your user experience, you generally assume that these such observation will have higher weight compared to other these observation. For perfect correlation, which is row positive one and negative one can establish a covariance and cofactor matrix, but no weight matrix. Please remember, weight matrix is always associated with observation, and it is much clear that it will only follow this relationship of inverse of cofactor matrix in case of uncorrelated. Okay, that means our understanding towards developing this cofactor weight matrix is is true for the case of uncorrelated, where your uncorrelated means, now yes, an important point, because many of you would not be following uncorrelated because of one reason or another. Uncorrelated means this is only diagonal matrix is there, rest all components are zero. This is called as uncorrelated. There would be certain value here, and I'm talking about the variance covariance matrix. Only variance covariance matrix give you indication about the correlation or uncorrelation understanding. Okay. Now, what is important is, as I've told you, what is most important, many times a student confuses this part. It is associated with raw observation. That means whatever you collect in the field, it is associated with raw observation only, and it cannot be propagated. Errors can be propagated, but weights cannot be propagated. And the reason is very simple. It is very much simple, because you can realize it that if you a certain weight is assigned to a observation, it will stick to it. Errors in the observation will go, but the weights cannot go. Weights is something which is relative in nature, and that is with stick to always observation. That's why the last uh, um, line is saying, since covariances can be derived from observation directly, whereas weights cannot, the concept of weight is considered as a secondary concept. Be careful when using terms weight. That means is given. First quantity will come as Q, then will come as W. So W is a secondary concept. So sometimes again, for the sake of your understanding, how I would write, I would write as, if you have access to population, you will have sigma, that is variance covariance matrix. If you have access to population, if you have access to sample, you will have Q, that means cofactor matrix. If you have access to sample, then you will have Q and associatedly W, if and only if the individual observations are uncorrelated. If they are correlated, then the relationship between Q and W will not hold, and you have to individually assign weights to observations based on your experience or any kind of information available to you. Any doubt? Any doubt? So should we move ahead? Now, this I want you to prove. Many of you would be following it, the content from many time. Now, I ask all of you to prove this, because if you prove it, this will give much more confidence to your understanding. It is by theory, it is written that the standard error of mean is sigma by root n. But how it can be proven? I am giving you 5 minutes to prove it. Because if you write the basic equation, because what I am asking is standard error of mean, which is sigma x bar. If you know how the x bar is written, if you know how the x bar is a function of what, then you can easily derive it with the help of law of error propagation, which I have just discussed with you. I'm just giving you all hint that are required.
सर कैपिटल एक्स को लिख ले, अगर x1 प्लस x2 xn लिख ले, मतलब x नंबर को ऐड करना है.
ओके, गुड.
और फिर इसका मीन निकाल ले तो x बार आ जाएगा, मतलब टोटल सिग्मा x अपॉन n आ जाएगा.
कैसे आ जाएगा, वही तो मैं पूछ रहा हूँ.
सर ऐड करेंगे अपॉन मीन, तो यही होता है ना, टोटल अपॉन
मीन से मतलब नहीं है. हमने आपसे क्या पूछा है, पहले फोकस करिए क्वेश्चन पे. हमने आपसे मीन नहीं पूछा है, हमने आपसे पूछा है व्हाट इज द स्टैंडर्ड एरर ऑफ मीन. आपका पहला
तो
स्टेप सही था.
पहले वे फिर उसका वेरिएंस निकाल ले और फिर उसके बाद उसका स्टैंडर्ड डेविएशन निकाल.
कैसे वेरिएंस क्या होगा, वही तो मैं जानना चाह रहा हूँ. वेरिएंस क्या होगा,
मतलब वेरिएंस x1 आएगा प्लस वेरिएंस x2 आएगा, xn आ जाएगा.
जल्दबाजी नहीं, पहले हवा में बातें नहीं, कॉपी पे लिखिए. आलोक.
यस सर.
बताइए, कर रहे हैं.
यस सर.
कैसे कर रहे हैं.
सर अगर हम मान लेते हैं कि y एक फंक्शन है और x1 x2 और xn तक, मतलब इसके कंपोनेंट्स हैं। उसके बाद y का वेरिएंस जब लेंगे तो लीनियर फंक्शन बनेगा, तो 1 स्क्वायर और वेरिएंस ऑफ सबका फिर n टाइम जुड़ जाएगा, और रूट रूट जब लेंगे दूसरे साइड तो अंडर रूट n आ जाएगा।
नहीं, जुड़ तो जाएगा, उसके बाद वाला स्टेप क्या होगा? उसके बाद वाला स्टेप,
हाँ, जो सर जोड़ देंगे तो फिर n टाइम्स हो जाएगा ना।
लेकिन उसके लिए एक एजम्पशन लगेगा, सीधे नहीं होगा, एक एजम्पशन।
सारे वेरिएंस जो होंगे हर टर्म में वो बराबर होने चाहिए।
हाँ, तो पूरा स्टेटमेंट बोलिए आप लोग, अब टेक्निकल नॉलेज अब आप लोग को थोड़ी बहुत आ गई है, पूरा स्टेटमेंट बोला करिए। हाँ,
और उसके बाद सर जब y का वेरिएंस लिखेंगे तो स्क्वायर वाला टर्म उधर चल जाएगा, तो फिर स्टैंडर्ड डेविएशन में सिग्मा अपॉन अंडर रूट n हो जाएगा।
गुड गुड। हम्म। रुचि,
Yes, sir.
how are you feeling now?
Sir, now it is good.
Your health is okay now?
Hello.
I'm asking, your
Sir,
health is
voice are
okay
you, sir?
now? Yes, you
Sir,
are
yes,
audible.
but not so good, sir.
Okay. तो भगत,
Yes, sir.
is it clear?
No, sir.
क्यों भाई, तुम तो यार सही चल रहे थे, क्या भटक क्यों रहे हो इधर उधर?
सर ड्राइव करने समय आता है, मतलब सिग्मा का फॉर्मूला का रूट n से डिवाइड करेंगे तो आज तो जाएगा, लेकिन फिजिकल इसका जो यूज है वो नहीं समझ में आ रहा कि इसको फिर स्टैंडर्ड
फिजिकल
एरर
यूज
क्यों
भी,
निकाल रहे हैं।
हाँ फिजिकल एरर भी बताएंगे, समझिए पहले। x bar is a function x1 plus x2 plus x3 xn. Okay, this is a function similar to y is equal to xn, like this. Is it, my screen is visible?
No, sir. No, sir.
बताया करो भाई, तुम लिखना चालू कर देते हैं। तो I was saying that your function x bar is written as x1 plus x2 plus x3 plus xn divided by n, and it is similar to your function, just like we were given example of y is equal to fx1, function of x1, x2, x3 and xn. Now it is a linear function, as Alok said, it is a linear function, isn't it? So how the linear function will move ahead? If you have to write, sigma x bar square would be sigma coefficient 1 square sigma x1 square 2 sigma x2 square sigma x3 square and sigma xn square. Knowing that all the individual observation are contributing or having equal variation, that means sigma x1 square is equal to sigma x2 square is equal to sigma xn square is equal to sigma square, then what will happen? Sigma x bar would become n sigma or simply sigma I just forgot one addition, that all would be I have taken one common as 1 upon n square, because all would be the coefficient of uh, x because it is divided by n, so everyone would be having 1 by n, 1 by n, 1 by n. If you want to understand like this, then it would be okay. So it would be n square, and then it would be sigma square by n. So obviously sigma x bar would be sigma by root n. Now this was the mathematical proof. And as Bhagat was saying, what is the physical significance? That's very good question. Good question in the sense, because ultimately, if you are talking about observation, your observation is something which should go ahead, isn't it? What we are interested in, the how observation or how good quality observation is affecting our mean. So by this relationship, one can easily see, I'm just removing the last this for discussing this. So from this relationship, what we can see, we can see that if you take large number of observation, if you take large number of observation, then the standard error in mean or deviation in the value of mean or range of mean would be less. If this is large, this would be less. That's how the relationship works. But standalone, this will not solve the problem. That means merely taking large number of observation is not going to help you. That should be supported by individual observations should have their own variation at the minimum level. So if observations are large in number as well as they are individually very much precise, then only this sigma x bar is realistic, or it would be highly precise. Because ultimately, if you've seen the previous example which we were giving in many of the discussion part, we are writing mu plus minus sigma, isn't it? If you just take the first example, I've given you the angle information is 30° plus minus 1 minute or 1 second. What does this mean? This means that you have taken n number of observation, and after taking n number of observation, you have taken the mean, then you have taken the its variation. So whenever you are representing some quantity as mu plus minus sigma, you are representing it by its mean value as well as the variation in the mean value. In this slide, we are more focused toward how this variation can be minimized. This variation in the mean is minimized only and only if you take large number of measurement with highest possible precision. Still, if it is not clear to many of you, I would again elaborate it with one more concept. How alpha is computed? Alpha would have been your instrument, or you in person have taken alpha at 10 times. The reading you have taken 10 times. That becomes alpha 1, alpha 2, alpha 3 and alpha 10. Isn't it? And the alpha up, these 10 observation will define the mean, and variation in individual measurement will define the standard error in mean. This is the physical significance. It should be very much clear, because let me tell you very frankly, you would not find it any book, this kind of discussion, because it is very limited to your understanding how we have faced such kind of problem in field, that by taking 10 observation, by taking 15 number observation, are we going to meet that kind of standard which we have set? Are we going to meet that kind of tolerance level? So these kind of thresholds of taking the final observation will only come forward if you have enough confidence in your procedure. Is it clear?
Yes, sir.
Okay. And finally, just like your variance covariance propagation, which we have studied like this, sigma yy is equal to a sigma xx a transpose, sigma yy as Jacobian sigma xx Jacobian transpose, their corresponding cofactor matrix propagation is also followed in a same manner. But what is more important, that the propagation of weight matrix is not done, not allowed, it is prohibited. Weights cannot be propagated. तो आप cofactor matrix तक you can apply, but you cannot go ahead and apply the same to weight matrix. So I hope it is very clear. Next, I am moving towards generalization of cofactor covariance propagation, and I'm leaving it to you. I'll share the slide and you will quickly go through. It is very simple. I mean, there are in literature there are various types of mechanism have been constituted, which talks about intercorrelation. As I've discussed, y is equal to ax plus b, z is equal to bt plus b. Then what is how q z y z would be related? You have proven in the previous example a q x t b transpose. Okay, and q y z is in the case of non-linear, it becomes Jacobian q x t z zt j transpose zt. So it's very much clear, because how you are doing it. See, yx is coming from the first one and zt is coming from the second one. If you prove it also, you can do it, but I'm leaving it to you, the derivation part. And it would be least used also in your example, any kind of problem solving, but still content is given to you, you can go ahead. It is talking about the generalization of cofactor and covariance matrix propagation. Okay, and it is example is given by the certain proof which now you can follow, and I'm leaving it to you. Then you have the propagation in a stepwise manner, again the extension of the previous example, so you can quickly go through it, but the basic is always same. You should always remember that y is equal to ax plus b is given and it is a linear model. You will write sigma yy as, or QYY as A sigma XX A transpose. If it is a non-linear, you will write QYY or sigma YY as Jacobian sigma XX Jacobian transpose. The reason for writing sigma YY represents if Y is a vector, it would discuss about Y1, Y2, Y3, Y4, Yn, all possible cases. The reason of writing YY or XX is simply representing if it is a vector of n variables, how would you represent? आप बार बार ऐसे तो नहीं लिखना चाहेंगे, ऐसे तो लिख नहीं सकते Y1, Y2, Y3, Y4, Yn ऐसे तो लिखेंगे नहीं, तो इसी को एक शॉर्ट नोटेशन दिया गया है to include all possible operation. You simply write YY, that's it, because this also create a lot of confusion among many students कि सर YY क्यों लिख रहे हैं हम डबल ट्रिपल Y क्यों नहीं लिख रहे हैं इस टाइप से. Many times students have asked like this. But simply speaking, you cannot write Y1, Y2, Y3, you know, like Yn every time. So you are representing it by simple notation, which is sigma YY. That's it. To represent it in a vector formation, matrix formation. तो आप इसको देख लीजिएगा, जैसा इसमें कोई रॉकेट साइंस नहीं है, बहुत आसान है. ओके Then obviously the propagation of covariance is explained with the help of function. So y is a function of x, z is a function of t, zyx you will write like partial derivative, zyt jzt would write as del z by del t. Then you have a vector r which is a function of yz, s is a function of xt. Then you will write a new function which is JRS as like this. It is very simple and there should be no confusion, because in whatever manner you can write, end product will not change. End product will remain same in whatever manner you can write it down. Okay. If you have any question, you can ask.
सर एग्जांपल नंबर 7 मिथाइल एंड ग्रीसी से नहीं समझ में आता.
अरे अभी पहले ये पढ़ लो, फिर उसको भी हम लोग देखेंगे. Okay. So similarly, you will write this by substitution. All these are very basic multiplications. You can write it in whatever manner you want. The end product is just constitution of cofactor matrix. Okay. So we are going to take one more example which you have done, and let us see how you are following it. This example. So example 2 is very simple. Do not look at the final solution right now. Just think in, I have given two measurements, y1 and y2, that represent your so-called field measurement obtained in meters as 100 plus minus root 3, y2 as 200 plus minus root 3, and sigma y1 by 2 as 100. So first of all, you would realize that how would you write it, because ultimate problem is if you do not able to write it, then there will be problem. So y1 is nothing but mu y1 plus minus sigma y1. Okay. Then mu y2 is written as mu y2 plus minus sigma y2. Okay, and sigma y1 y2 is 100. So how would you write sigma yy? How would you form sigma yy? As sigma y1 square, sigma y1 y2, sigma y2 y1, and sigma y2 square. That's how you will form the variance covariance matrix. Okay. The moment it is given, any kind of observation is given as certain value plus minus or certain value as plus minus. So you immediately try to look that the first component, that means plus minus के जो left वाला component है वो mean को represent करेगा और right वाला component standard deviation को represent करेगा. Okay. It will represent the standard deviation. Okay. Now let us move ahead. It is saying that y1 is this, y2 is this, sigma y1, y2 is this. Given y1 as 2x1 minus x2, y2 as x1 plus x2, and quantity z1 is equal to x1 plus x1 square plus x2 square, compute sigma zz. Now what it is doing? It is computing sigma. It is asking for sigma zz. तो आप कैसे करेंगे इस प्रॉब्लम को? तरीका है. सबसे you will start with the given function y1 y2, you will write it like this, then you convert into matrix formation by taking x1 x2 on the as a common or whatever you call it, and you will write y is equal to ax. Then your a matrix is 2 minus 1 1 2 and x1 x2. Now it is function as y is equal to ax. It is a linear function, very much clear. It is a linear function. For linear function, what would be the open an error propagation? A sigma xx A transpose. If it is A sigma xx A transpose, then it is written as sigma y1 square, sigma y1 y2, sigma y2 y1, sigma y2 square, and then this is you are opening the sigma yy. Then on the right hand side you will have A sigma xx A transpose. What is A? A will like this, A transpose, then sigma x1 square x1 x2, then sigma x2 x1 and sigma x2 square. You know what you know, you put it down 300 3 because you know from y, you know A transpose, you do not know this sigma xx. Okay, that is one thing, you do not know sigma xx. Then the next function which is given as sigma x1 square plus x2 square. There is a non-linear function. So for non-linear function, you have to write like Jacobians. How would you write? Jacobian would be 2x1, 2x2. Okay, but Jacobian has to be computed because it has to be estimated. Then you need the value of x1, x2. From where you can compute? From your basic mathematics, you try to solve this equation. You will get value of x1, x2. The moment you get the value of x1 and x2, you put it down here in Jacobian transpose, and solving this equation by opening the multiplication, you can get the value of individual component, which you put it down here, and then you will solve it. So this is your basic, from your basic understanding, you are doing it. But forget about any other thing, just stick to your basic. If it is a linear, you will write a sig. So this problem consists of both linear as well as non-linear. The first problem, the first relationship y1 y2, they are in linear relationship with x1 x2, but z is in non-linear relationship with the x1. So no need to worry. First a sigma xx A transpose, and then second one is j sigma xx J transpose. Just take a look. I'm erasing. Just take a look. Any question? If you have any doubt.
जैकोबियन बनाया था सर, वहां तक तो सब समझ में आ गया सर, उसके बाद फिर कैसे करेंगे वो समझ में नहीं आया सर। यहाँ लास्ट पार्ट तक पूरा समझ में आया सर, जहाँ तक आपने जैकोबियन बनाया था 2x उसका डेल निकाला था सर, उसके बाद कैसे करेंगे?
Now तो अब now you see here you have 2x1 2x2, isn't it? But you do not know the value of x1 x2. But is there any information given? Yes, you can solve this y1 y2 by mean values. You put mean value of y1 in function, because this is deterministic models, they are deterministic models. What you can do, you can put in the mean values to find out the mean value of x1 x2. Okay, so you can get the x1 x2. So from that you can evaluate z, and from above comparison from both side after matrix multiplication, you can easily compute the sigma xx, which you can insert here. Now you will get the solution.
Okay, sir.
I have done only half away. That means you have to do it first by comparison from both sides. You have to compute the sigma xx. Second, first step is sigma xx by comparison. Second step is finding out the x1 x2. Third step is putting it here. All these two values you have to put it here.
सर
हाँ बोलिए।
सिग्मा वाई वाई में सिग्मा वाई वन स्क्वायर की वैल्यू 3 और सिग्मा वाई टू की वैल्यू 3 कैसे हो गई सर?
अब आप खुद ही देखिए। आलोक बताइए, आप ये एफर्ट करिए, थोड़ा बताइए। क्वेश्चन उन्होंने पूछा, ये वैल्यू 3 कैसे हो गई? प्रवीण ने बताइए।
सर कहाँ पे है?
ये वैल्यू ये पूछ रहे हैं, मैं हाईलाइट कर रहा हूं।
y1 और y2 में देखो हुआ स्टैंडर्ड डेविएशन, फिर जब उसका वेरिएंस निकालोगे तो स्क्वायर कर दोगे तो √3 का स्क्वायर 3 हो जाएगा।
This is what I was telling from previous slide also. आप इसको ऐसे पढ़ेंगे, जब भी कोई प्लस माइनस का नोटेशन आपको दिया जाएगा तो आपके लेफ्ट हैंड साइड में म्यू, राइट हैंड साइड में सिग्मा। बट आपका जो वेरिएंस कोहेरेंस मैट्रिक्स को लिखने का तरीका होता है वो क्या होता है?
सिग्मा वाई वन स्क्वायर प्लस सिग्मा वाई वन वाई टू।
प्लस नहीं, सिग्मा वाई वन स्क्वायर, सिग्मा वाई टू स्क्वायर, सिग्मा वाई वन वाई टू एंड सिग्मा वाई टू। ओके, तो सिग्मा वाई वन स्क्वायर जब आएगा तो आपको तो पास तो सिर्फ सिग्मा वाई वन है, स्क्वायर करेंगे तो 3 आ जाएगा, वाई टू करेंगे 3 आ जाएगा, और सिग्मा वाई वन वाई टू आपको 100 दिया हुआ, एज इट इज पुट अप कर देंगे। यू गेट इट?
यस सर।
आपको किसी भी प्रॉब्लम से स्टूडेंट को घबराना नहीं है। आपके पास जो कुछ भी आपको पता है इन टर्म्स ऑफ योर अंडरस्टैंडिंग ऑफ द एरर प्रोपेगेशन, यू राइट इट डाउन। इफ यू नो व्हाट इज सिग्मा वाई वाई फॉर लीनियर केस, यू राइट इट डाउन। If you know non-linear, you write it down. Now you see the model. If it is linear, non-linear, If it is a linear, this will apply. If it is non-linear, this will apply. You should also know how the Jacobian will form. Rows will form according to number of function. Column will form according to number of variables. So आप Z में देखिए, Z is only one. There is only one function. So it would be 1 variables 2. So 1 cross 2. So Jacobian will form as 1 cross 2. यहाँ देखिए Jacobian बनी कि नहीं बनी 1 cross 2 से. It is only mere mode of practice. How much more you practice yourself, and then it will be no problem. हाँ भाई, कौन सी प्रॉब्लम में आपको दिक्कत है मिखाइल एंड ग्रेसी की जो आप नहीं कर पा रहे हैं? आलोक,
एग्जाम्पल 7 चैप्टर
एग्जाम्पल 7 की चैप्टर 6 का एग्जाम्पल
7 मतलब उसमें
ओके,
समझ
क्या है उसमें?
एक सेकंड सर।
हाँ, ओके। अब थोड़ा सा हम लोग करते हैं, पहले वो प्रॉब्लम करेंगे तब आपको डिस्कस करेंगे। सो गुड दैट यू हैव आस्क्ड।
ठीक है सर।
अब हम लोग करने जा रहे हैं, ठीक है? वही प्रॉब्लम करेंगे बट इन अ डिफरेंट मैनर। ओके, अब हमने आपसे क्या फॉलो किया था? यू डू नॉट फॉलो द बुक्स इन टर्म्स ऑफ इट्स नोटेशन। अब वो कैसे कर रहे हैं उस पर मत जाइए, आपको बेसिक फंडामेंटल मैथमेटिकल मॉडल प्रिपेयर करना है पहले। इफ यू कुड प्रिपेयर इट देन यू कैन सॉल्व एनी प्रॉब्लम। ओके, सो आई एम जस्ट using another screen. Okay, okay, okay. I hope it is visible now. Problem is very simple. First you listen properly. It's very good question because it will take, the discussion will take more than half an hour. What is the problem which we call it an inaccessible point problem? There is a problem in our Geo-Informatics domain. Always there would be some inaccessible points. Whatever mechanism you adopt, there will be such cases where what we are trying to say here by inaccessible point problem is that there will always be a case that you would not approach, or you will not go to that point by any means. Just like if you Google it, the Swiss Alps, if you just Google the Swiss Alps, so Swiss Alps, which is a mountain range on in Switzerland, and there is around 177 kilometer, high width lake is there, Geneva Lake, which we call very popularly. And on this side there is a road which goes from Geneva to Lausanne. Both two are the very popular cities of Switzerland. So you have Swiss Alps on the right hand side, and in between you have the so-called water body, which is Geneva Lake, which extend from I just this width is 35 kilometer. This is 35 kilometer. The stretch of this lake is around 177 kilometer. And on the left hand side you have roads, houses, and grassland. This is the problem. Now you cannot go to the bottom of this any mountain range with any instrument, because this is all the lakes are there. And suppose there is no boat available is there, and I am giving you one problem and let's say there is a one light tower on this size. there is a light tower. I want you to measure the height of this light tower. You cannot move in this direction. That means you cannot access this area. This is inaccessible. The whole understanding of your this is inaccessible area. You cannot access it. You have only this region where you can have access to with your all instrument. What you have to find out the light tower, height of light tower at this end. अब बताइए कैसे करेंगे इस प्रॉब्लम को?
सर ट्रिग्नोमेट्रिक सर्वेइंग करेंगे ना?
करेंगे टेक्नोमेट्रिकल रिलेशनशिप का यूज करेंगे, बट कैसे?
सर जो एक्सेसिबल एरिया है वहाँ पे 2 पॉइंट, मतलब हमें तो डिस्टेंस पता रहेगी, तो वहाँ से
चलिए मैं वो जो आप बोल रहे हैं मैं वो लिखता जा रहा हूँ. ये 2 पॉइंट ले लिए ए बी, और इसके बीच की डिस्टेंस आपको पता होगी. क्यों? क्योंकि आप यहाँ पर एक्सेस कर सकते हैं. यू कैन प्लेस योर इंस्ट्रूमेंट नेक्स्ट पॉइंट. फर्स्ट इज क्लियर? ओके.
सर उसके बाद टॉप मोस्ट जो टावर है उसकी हाइट वहाँ से अगर तो मैट्रिक सर्वे से
टॉप मोस्ट पॉइंट, लेट्स से दिस इज टॉप मोस्ट पॉइंट. ओके. इसकी हाइट क्या कह रहे हैं?
इसकी हाइट h और जो डिस्टेंस है a पॉइंट से उसके बेस तक का, वो दो में रिलेशन बनाएंगे.
ये चीज कह रहे हैं. ये
हाँ,
मेजर नहीं कर सकते ना आप इसे. यू कैन नॉट मेजर इट. हाउ कैन यू मेजर इट? जब आप एक्सेस नहीं कर सकते हैं 2 पॉइंट को, तो मेजर कैसे करेंगे? जब आप यहाँ जा नहीं सकते तो यहाँ से मेजर कैसे करेंगे? सोचिए भाई. आपने ए और बी कैसे मेजर किया? सभी लोग सोचे ए और बी कैसे मेजर हुआ? क्योंकि आप ए से बी को एक्सेस कर सकते हैं. एक्सेस मतलब अगर टोटल स्टेशन है तो टोटल स्टेशन एक स्टेशन पे लगा के रिफ्लेक्टर दूसरे एंड पे रख के आप डिस्टेंस मेजर कर सकते हैं. दैट्स हाउ यू हैव डन इट. बट you cannot reach it here. You cannot access this tower at all. Then how can you measure the distance? तो वो तो पॉसिबल नहीं है, तो वो तो ऑप्शन गया. अब आगे का स्टेप बताइए, आप क्या करेंगे? One observation only it is available right now. One observation is available, AB. That's it. अब बताइए अगला. सोचिए भाई. ये एप्टीट्यूड लेवल का क्वेश्चन है. जियो इन्फॉर्मेटिक्स का बाद में है. अरे आलोक बताइए.
से वर्टिकल एंगल मेजर करेंगे ए और बी.
ए और बी से वर्टिकल
एंगल पॉइंट पे. उसके
चलो
बाद
भाई एंगल वर्टिकल वर्टिकल एंगल मेजर किए, अब
सर प्रोजेक्शन ले लेंगे इसका।
किसका?
सर ये जो ट्रायंगल बना है इसका प्रोजेक्शन ले लेंगे ग्राउंड पे।
ग्राउंड पे प्रोजेक्शन लेने के लिए क्या चाहिए होगा?
फिर वही
ग्राउंड पे प्रोजेक्शन लेने के लिए क्या चाहिए होगा?
सर उसकी लेंथ।
तो है क्या वो आपके
सर
पास?
AB की लेंथ तो नोन है, तो वहां से सर अल्फा आ जाएगा यहाँ पे।
कौन सा अल्फा? हमें पहले पूरा बताओ तो, कौन से अल्फे की बात कर रहे हैं आप? भाई हमें थोड़ा सा समझ में आया कि कौन से अल्फा की बात कर रहे हैं, तो हम आगे
सर
बढ़े।
मतलब सर ये जो एंगल बन रहा है,
कौन सा?
ये
ये
लाइट हाउस
एंगल,
के साथ, लाइट हाउस के साथ।
ये वाला, ये
नहीं
वाला
सर, ये लाइट हाउस
वर्टिकल
वाला।
एंगल, लाइट हाउस वाला कौन सा?
सर ये ट्रायंगल जो बन रहा है,
ये वाला ट्रायंगल, ये दिस वन।
सर AB और लाइट हाउस से।
हाँ हाँ,
तो
बताओ
सर ये
आगे।
जो ऊपर वाला एंगल बन रहा है,
ये वाला, ये
यस सर।
कैसे मेजर करोगे इसको?
सर AB
हमें
पता
बताओ।
है।
ए भी पता है? हाँ,
सर रिवर ब्रिथ भी तो नोन है।
उससे वो तो मैंने आपको बताई, उसकी स्ट्रेंथ, वो लेंथ क्या है। फॉर योर कॉमन अंडरस्टैंडिंग कि देयर इज अ जेनीवा लेक व्हिच इज ऑफ दिस मच विड्थ। ऐसा प्रॉब्लम हमेशा थोड़ा होगी, कोई ऐसी लेक की चर्चा होगी।
पॉइंट बी से अगर एक इमेजिनरी लाइन टाइप की उसके बॉटम तक ले लेते हैं तो सर
हाँ,
एंगल मिल सकता है, क्योंकि एक तो हो गया और हमारे
इनफैक्ट
पास
विड्थ जो जेनीवा लेक की है वो 14 किलोमीटर है। I'm correcting myself, it is 14 किलोमीटर। खैर, फॉर योर नॉलेज ओनली, नॉट टू बी यूज्ड हियर। हाँ, कोई बोल रहा था क्या करें?
सर जो AB है वो
हाँ
तो
अरुण।
तो अगर हम ए से कोई पॉइंट उसके बेस पे ले लेते हैं तो उसके एंगल, उसके बीच का एंगल तो मेजर हो जाएगा सर, क्योंकि AB नोन है।
किसके
तो
बीच, किसके बीच के एंगल?
और जो AB है सर।
आवाज नहीं आ रही, फिर से बोलिए, तेज बोलिए थोड़ा।
आपने ड्रॉ किया है बॉटम को, और जो सर AB है
हम्म,
उसकी तो एंगल अब पता लग बस तो 2 है डेफिनेट। नहीं सर,
ये एंगल,
नो सर, A के पास वाला।
ये वाला। यू आर टॉकिंग अबाउट दिस एंगल।
यस, जो आपने ड्रॉ किया है।
हाँ चलो, ये तो मान लिया तुमने। एक एंगल तो तुम कर सकते हो, किसी को भी नॉर्थ मान के उससे एंगल दूसरे पॉइंट का ला सकते हो। तो तुमने ये आर्बिट्रेरी पॉइंट मान लिया, रेफरेंस पॉइंट, उससे तुमने एंगल कर लिया। तो व्हाट विल बी दिस एंगल? उसके बाद क्या करेंगे? उस एंगल का क्या यूज है? पार्टिसिपेट करिए भाई, बाकी लोग क्या खाना पीना खा के नहीं आए हैं? थोड़ा सा पार्टिसिपेट करिए। दो ही तीन लोग बोलेंगे तो कैसे काम चलेगा? चलिए, आप लोग को एक हिंट दे रहे हैं। जैसे इन्होंने ये जो इनिशियल ड्रॉ पॉइंट करवाया, उससे एक और पॉइंट यहाँ से भी इमेजिनरी सेम पॉइंट को कर दिया और ये एंगल मेजर कर लिया।
यस सर।
इसको हम एंगल बी बोल रहे हैं, ये एंगल ए है। उसे होगा क्या? चलो भाई, सुमित बताओ।
सर अभी सोच रहे हैं, अभी कुछ कंक्लूजन नहीं निकला सर।
तब तक तो कहानी खत्म हो जाएगी। आलोक आप बताइए।
तो साइन रूल लगाएंगे, जैसे साइन रूल, तो उसी तरह वो मान के।
चलो ये इमेजिनरी पॉइंट माना तो क्या लिखेंगे? ए आई
अपॉन साइन बीटा, हाँ ठीक, और ए बी आई बी इक्वल टू अपॉन में साइन ए, और ए बी हमें पता है ए बी साइन सी, और इसमें ए बी पता है।
आप बताइए।
तो सर ऐसे निकल जाएगा इससे,
क्या चीज?
सर कैलकुलेट हो जाएगा ना इसमें, हमें दो वैल्यू पता है, एक
ए आई बी आई आ जाएंगे।
हाँ
ठीक है। और अगर अब आप इस प्रॉब्लम को समझें तो हाइट ऑफ द टावर इज नथिंग बट ए आई तो एंगल ए एंड एंगल बी दे आर हॉरिजॉन्टल एंगल, अल्फा 1 एंड अल्फा 2 आर वर्टिकल एंगल। ये डिफरेंस है दोनों में। जो ए आई है वो क्या है? ए बी साइन बी अपॉन साइन और so there are two, one from point A, another point B. So H would be given as final mathematical model. आलोक क्लियर हुआ?
यस।
Any confusion to anyone? आप चैप्टर जो भी आपने प्रॉब्लम बोली 7 और 8 जो भी है वो सब खत्म, उसके बाद कुछ बचा नहीं उस प्रॉब्लम में। Okay, any doubt? In this? बाकी लोग यार रिस्पांस नहीं दे रहे हैं, इसका मतलब समझ नहीं आया है क्या अभी तक? सुमित?
ये सर समझ गया सर, समझ में आ गया।
बहुत देर में समझ रहे हो आजकल तुम।
हाँ सर, एक हफ्ते से सर क्लास ठीक से नहीं हो पाई थी सर, इस वजह से थोड़ा सा बीच बीच में चीजें छूट गई।
चलिए भाई ठीक है। यशोवर्धन,
यस सर।